Right, now we're going to do prime factors. Now, in order for us to do prime factors, we firstly need to know what is the word factor. So we learned in our previous video that factors are actually numbers, a number that can go into a whole number without having any remainder. Now, prime factors are the same thing, but we have to know what prime means. Now, a prime number are numbers that have only two factors. So a prime number has two factors, the number 1 and itself. Okay, so those are what prime numbers are. Now, giving an example of that would be, we are starting with the number 0. 0 doesn't have any factors. 1 doesn't have, only has itself, so that's not two factors. Then we have 2. The factors of 2 is 1 times 2 and 2 times 1. So what are the factors of 2? It's only 1 and 2. So number 1 and itself. The next number is 3. 1 times 3. Yes, so this is a prime number. Next, 4. 1 times 4, 2 times 2. Now, can you see here? This has two factors, this has two factors, but this has 3 factors. Now, that's another, this has a certain name for it. These two are called prime numbers, but this is actually going to be called a composite number. So composite numbers are numbers that have more than 2 factors. So basically 3 factors and above, right? So those are called composite numbers. So this is not a prime number, this is a composite number. Then we go to number 5. 5 has 1 times 5 and 5 times 1, so that's a prime number. 6 has 1 times 6, 2 times 3. Nope, not a prime number. Next we got 7. 7 we got 1 times 7, that's a prime number. Then we got 8. 1 times 8, 2 times 4. Nope, not a prime number, it's a composite number. Next we have 9. We have 1 times 9, 3 times 3. Nope, it's a composite number. 10. 1 times 10, 2 times 5. Next we have 11. 1 times 11. And anything else? Nope, so it's a prime number. Next, 12. 1 times 12, 2 times 6, 3 times 4. Nope, that's a composite number. So I'm going to go and try to find, let's see how many we got so far. So we got, this is a prime number, this is a prime number, so 2, 3, 4, 5. Let's find the first 10 numbers. So 13, yep, 1 times 13, so that's 6. Then we have 14, 1 times 14, 2 times 7, nope. Then we got 15, 1 times 15, 3 times 5, nope. Then we got 16, 1 times 16, 2 times 8, 4 times 4, nope. Then we got 17, 1 times 17, yep, that's a prime number. And then we have 18, 1 times 18, 2 times 9, 3 times 6, so that's a composite number. 19, 1 times 19, that's a prime number. Let's see how many got. 1, 2, 3, 4, 5, 6, 7, 8. Let's just stop here. So the first 8 numbers of prime numbers would be 2, 3, 5, 7, 11, 13, 17, and 19. And the other numbers are all called composite numbers. But where does the number 1 lie? Number 1 has 1 times 1. So the only factor that 1 has is 1. So a prime number has 2 factors. A composite number has more than 2 factors, 3 factors and above. So a number 1 is neither a prime number nor a composite number. It's just a neutral number. That's a very important fact to remember because many people get confused when they do that. Now we're going to move on to prime factors. So we know what prime numbers are. Now we need to know how to do prime factors. Now prime factors can be done in two ways. Prime factors can be done through the tree method or through a ladder method. So a factor tree. So if I have the number 36, I'm going to do it in two methods, right? So let me use two different colors so I don't get confused. Right. So my one method, this is going to be my ladder method, and this is going to be my tree method. Now remember, we're doing prime factorization. Now prime factorizations are where the prime numbers must be the final factors. Okay, so we start here. We pick any number. So we say what times what can give me 36. So you can take any number you feel like. So I'm going to say 9 times 4. Right. But is 9 a prime number? Nope. Is 4 a prime number? Nope. If they aren't prime numbers, then you need to further break them up again. So I'm going to say what times what gives me 9. So I'm going to say, right, 3 times 3. Are they both prime numbers? Yes. Then I make a circle around them, meaning that those are my final answers from this branch here. Then I have 4. What times what gives me 4? So it's 2 times 2. Are they both prime numbers? Yes. So I circle them. So then I say my factors, my prime factors of 36 are equal to. I use multiplication between these numbers, and I start from the smallest numbers to the biggest numbers. So I say 2 times 2 times 3 times 3. And how many 2's do I have? I have 2 2's. So I say 2 to the power of 2 times. How many 3's do I have? 2 3's. So I put 3 to the power of 2. And that's my final answer. Now how do you know if your answer is correct? If you multiply it out, you must get 36. So 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 36. Now we're going to do the ladder method. In the ladder method, you're going to get exactly the same results. But the ladder method is normally used because in the bigger grades, it's more easier to do it this method. So when you do the ladder method, you must always remember that you need to start with the smallest prime number that can go into it. So the first prime number is 2. Can 2 go into 36? Yes. 2 goes into 3, 1 time, remainder 1. 2 go into 16, 8 times. Then you continue using the same number. So we're still going to continue using 2. Can 2 go into 18? Yes. 2 go into 18, 9 times. Right. Then we say, can 2 go into 9? Nope. 2 can't go into 9. So what's the next prime number? The next prime number is 3. So we start with 3. 3. 3 can go into 9 3 times. Can 3 go into 3 again? Yes. And then I get a number 1. When you do the ladder method, you must come to the number 1. When you come to the number 1, then you know your ladder is complete. Then I say 36 is equal to 2 times 2 times 3 times 3. And I get 2 to the power of 2 times 3 to the power of 2. You see, I got both the exact same answer. Now I'm going to give you a number and I want you to do it in both methods, and let's see if you can get them correct. So if you did it the correct way, you would have done it like this. So if I had to make my tree, I say 72. What times what gives me 72? So I can use any number I feel like. So I'm going to be like, what number could that be? What times what can give me 72? So if you can't remember anything, you just try to use your prime numbers, or your factors. You'd be like, okay, 72, half of 72 is 36. Okay, so let's say 36 times 2. Now 2 is already a prime number. So then I'm going to be like, okay, let me break this up. What times what gives me 36. So I know 6 times 6 gives me 36. But those two are not prime numbers, so therefore I need to break them up further. So when I break them up further, I'm going to say 2 times 3. Those are prime numbers. And this one here, 2 times 3. Those are also prime numbers. So finally, 72 is made up of, we start with the smaller numbers, so 2 times 2 times 2, and then we go to the next bigger number, which is 3, and another 3. So how many 2's do I have? 3 2's. So 2 to the power of 3. How many 3's do I have? 2. So 3 to the power of 2. And that's my answer. Then I'm going to go do the ladder method and see if I came right with my ladder method. So when I do the ladder method, remember you always start with the smaller number. The smallest prime number. The smallest prime number that can go into it is 2. So 2 going to 7, 3 times, remainder 1. 2 going to 12, 6 times. You say 2 goes into 36, 18 times. Then you say, can 2 go into 18? Yes, 9 times. Can 2 go into 9? Nope. So we go to the next prime number, which is 3. 3 go into 9, 3 times. 3 can go into 3 until I get a number 1. And then finally, I say 72 is made up of, and then this is much more easier way because you're going in order. So your numbers are just lined up for you already. 2 times 2 times 2 times 3 times 3. So you have 2 to the power of 3 times 3 to the power of 2. And that's all. Quite easy, hey? Good luck.